Everyone, so today we'll look at this question, maximum distance in arrays. Okay, so what is the question asking about? We're given an M arrays where each array is sorted in ascending order. So this is very important. We may use it in a condition. And we can pick up two integers from two different arrays. Each array picks one. Okay, so each array picks one. So that means we cannot pick two integers from the same array. And calculate the distance. We define the distance between two integers, a and b, to be their absolute difference, a minus b, absolute value. And then return the maximum distance. So the input arrays is 1, 2, 3, 4, 5, 1, 2, 3. Here in the first example, the output is 4. Why? Okay, so choose 1 as a minimum. And what's the maximum? Is here, 5, right? So 5 minus 1 is 4. Okay, so, and also we can choose this one as well. So this one in the last list, 5 minus 1 is also 4. Okay, so this one, second example, arrays 1 and 1. 1 and 1, 1 minus 1 is 0. So the output is 0. Okay, so in this question, there are several ways to do, right? First way may be a brute force approach. So we go through all the elements from the beginning to the last, and then we iterate and find what's the maximize and minimum value for each for each like array, right? For each list. And then we find that value and we do some exclusions since two values cannot come in from the same list. So we do that checkings and then we can get the results. But that's still a little bit complicated, to be honest. And also the runtime is not good because as we can imagine, there's going to be a lot of nested for loops. So what about some better approaches, right? So do we have some better approach? So what are we going to do here? Our approach. So as we notice here, ascending order is highlighted. So what should we do for ascending order? A ascending order means these values, for each different sub-arrays, the values are strictly in ascending order as it says. So can we use these conditions? I'm pretty sure we can, right? So we know for each array what's the minimum and the maximum. So we don't really need to do for loops in each sub-arrays. We can just using our index to know to get the smallest and the biggest directly. Okay, so let's firstly define something. Smallest, right? So what is the smallest and what is the biggest for each sub-array? So smallest, let's say for this in this example, the smallest is 1. Okay, so the input is arrays at index of 0, and at index 0 is definitely the smallest. What's the biggest for the first subarray? Then that's gonna be 0 and -1, as we can use -1 indexing in Python to get the last element. Okay, so we get the smallest and the biggest. What's the next step, right? So we need to do some comparisons, and which means we need to iterate from the first subarrays to the last one. So for I in range length of arrays. Okay, so what do we want to access, right? So before that, I need to decline a result, which is 0. This is something we want to output. And for I in range, length of arrays, right? What we need to do here is we want to get two things. One is the biggest, and one is smallest. Besides that, we still need to know the distance, right? So what's the largest distance when we are comparing to the subarrays that we're using, which means, okay, so let's say in this scenario, 4 and 5, we already iterated 1, 2, 3, though we get the smallest as 1, biggest as 3, although it might not be a good case here because we can't use 3. So which means, actually, I want to add something here. We need to iterating from 1 because if we go like it, because we already have the smallest and biggest, if we go again, from 1 to 3, then what we're gonna happen is we just do it again, which doesn't make any sense. We only need to do from 4 and 5. Okay, so for 4 and 5, what we want to know is if we use like these values, then what's gonna be the the largest distance, right? So it's gonna be max curve distance is gonna be the max of we want to use here is um okay, actually I want to declare curve array so that's easier to use. It's gonna be arrays at index of I, and max curve is gonna be the max of curve array at the last index minus what? The smallest, right? Smallest. And biggest minus curve array at 0. Okay, so that's the max we want to get here. What's next? So smallest is, we want to get the new smallest. So smallest is gonna be min of the smallest that we already have, and the current smallest, which is curve array at 0, and biggest is gonna be the max of biggest and the current array at -1. Last but not least, we need to update the result, right? So result is gonna be the max of result and curve and max curve. Okay, so lastly, after the for loop, we can return the result. Let's see. All right, accepted. Okay, good. So what's the runtime? Runtime, since we only have for loop, so it's gonna be big of n as the input size, and I mean like the length of the arrays, which means the number of subarrays in this condition. And also for the space complexity is gonna be big O of 1 because we only keep track of those like constant values and they only update for each iterations. And the length is like quite straightforward. So we only have this like limited amount of variables that we need to keep track of. And we only store this, which means it's gonna be a big O of 1. Thank you so much.